Okay, for those of you that are tuning in to watch the live stream, we'll begin in just 1 second. We have some people filtering in to the main seminar room. So just one moment. Okay, I might actually just start so that we have enough time for questions and conversation at the end. So good morning and thank you for joining us for our first hybrid seminar of this type. We're going to see how this goes today. It's my pleasure to introduce today's speaker, Dr. Michael F. Wehner of the Computational Research Division at the Lawrence Berkeley National Laboratory, who's calling in remotely to join us virtually in the Mesa Lab main seminar room. So Michael will be presenting to us on end-to-end attribution from hot air to environmental injustice. Michael holds a bachelor's from the University of Delaware in physics and a master's and PhD from University of Wisconsin-Madison in nuclear engineering. Prior to joining LBNL, he was an analyst at the Lawrence Livermore National Laboratory in the program for climate modeling diagnosis and intercomparison. Currently, Michael researches the behavior of extreme weather events in a changing climate with focus on heat waves, intense precipitation, drought, and tropical cyclones. He is author and co-author of over 250 scientific papers and reports. He was lead author on the 2013 fifth IPCC assessment and is currently one of the primary authors on the recently released sixth IPCC assessment report, as well as on the second, third, and fourth U.S. National Climate Assessments. And he is also working now as a lead author on the fifth National Climate Assessment that just opened for public commentary, which is due out in final form, I think it said, in late 2023. He's also made a variety of media appearances and presentations, including on Hurricane Ian, providing information on the human influences on the extreme precipitation experienced during the event, as well as human influences on the 2021 Pacific Northwest heat waves. He's discussed the increased costs of hurricanes due to global warming and provided testimony to the U.S. House of Representatives Select Committee on Energy Independence and Global Warming in 2010 on extreme weather under a changing climate. So before I hand it over to Michael, a quick note on how we're going to handle questions in this format. So if you're in the room, we'll do as we would do in a regular in-person seminar, where you will raise your hand at the end of the presentation. I'll hand you the microphone and you can address Michael with your question. If you're watching online, go to the Slido page for the seminar series, which you can just go to slido.com and enter hashtag CGD seminar to get to our page. And I will take those questions during the question and answer period alongside the in-person questions. So Michael, your screen looks good and I'm gonna hand it off to you.
Well, thank you very much, Monica, and for that nice introduction. And I would like to highlight that the fifth National Climate Assessment is now open for public comment. I would encourage all of you to look at it. There's a lot of chapters, something for everyone, and it's only as good as the feedback that we get. So please take a look. It's open for 12 weeks. As my title says, I'm going to talk about what I call end-to-end attribution, and this is sort of going from what we know about global warming to what matters to people. This is a picture of an event that mattered to a lot of people. This was Hurricane Harvey in Houston. And you can see the flood was such that people had boats out in the street. It's quite a devastating event. And most of what I'm going to talk today uses Hurricane Harvey as an example, but I believe what I'm going to talk about extends to other kinds of extreme weather disasters. I have a standard disclaimer that this is just me speaking and I'm not representing anybody that I might work for. So not all of you may be familiar with what extreme weather event attribution actually does, it really looks at two different questions for an individual event. This was something I did for the 2021 Pacific Northwest heat wave using a version of CAM5, meaning atmospheric model from NCAR. And we asked two questions. How is the probability of this event at an observed magnitude change because of climate change? And how did, and the second question, which seems to be different, but actually is just the flip side of that question, is how did climate change affect the magnitude of this event at a fixed estimated rarity? And this picture here on the x-axis shows the return period. That's like, how many times it would happen once in, say, 100 years, if it was a 100-year return value. And the return value is on the y-axis in degrees Kelvin, and on the x-axis the return period is years. And so if we said, okay, let's say it's a 100-year event, and for this first question, we say, well, if the observed was, there were 315 degrees, or 315 kelvins, if in the world that was, which is this red curve, we go down to, in slicing in the vertical, we can go down and say, well, in the world that might have been in this other simulation, we can say that it would have been about 2 degrees cooler. If you slice in the horizontal direction, you can ask the probability question. Say, let's say 314 degrees. In the real world, the world that was, would have a return period of, say, I don't know, 30 or 50 years. But in the continuing on in that direction, on the blue curve, in the world without climate change, it was a much rarer event, maybe 200 years or 300 years. And so those are the two questions. And typically, we express the first one as a ratio of the probabilities, and we'll say something like climate change made this event 30 times more likely, or we could say climate change made the event 2 degrees warmer. And those are equivalent statements. The public attention and the media picks up on this a lot, and there are good and bad reasons for that. But the media often picks up on the probability change because 30 is bigger than 2, and that's what reporters like to write about. But what I want to go is go another step and say, how did climate change actually affect not just the weather but people? And so these are impacts, and impact questions are slightly different. Questions might be like, how much did climate change cost in this event? How much more expensive was it because of climate change? Or how many more people died because of climate change in this event? Which is sort of a very personal question, which leads to one we're going to look at, which is, did climate change flood my house? Can we actually answer that question? And did climate change kill my loved one? I mean, oftentimes in heat waves, the ones who died are somebody's grandmother or somebody's grandfather, and you want to know, I think people want to know, how did climate change affect that? And these may or may not be tractable questions, and they're probably going to be answered in some probabilistic framework. But fundamentally, they seem to be linked mostly to the change of the magnitude question, although not completely. So I mentioned I was going to talk about Hurricane Harvey. Here's a satellite image of Harvey just as it making landfall on the Gulf Coast in Texas. And the reason that Harvey was such a devastating event is it's very unusual in that it stalled. And you can see here the track with the dates being in August and then later in September being shown as the numbers. And around the 25th, it just hung out until, say, 4 days later, right off the coast. And so as it's, let's see if I can go backwards, as it's spinning around here, it's dumping rain in the greater Houston area. And then as the motion goes around, it's picking up more moisture again off the Gulf and just dumping it. And so, it made copious amounts of rain. And I don't think that we can make any statement about the stall and climate change. I mean, it's too rare of an event. There aren't enough analogs in the observational record to really make a statement. But we can make a statement about precipitation. And indeed, 3 independent groups made statements about the attributable precipitation increase because of global warming. And all of these made best estimates that surprised me, in that they were greater than the Clausius-Clapeyron scaling relationship. Now, for those of you who don't know, Clausius-Clapeyron is a 19th century a scaling law, really, developed by these two guys to help make steam engines more efficient. So this is not new technology. And what it tells us is that saturation-specific humidity increases at about 6 or 7% per degree centigrade of warming. There was about a degree of centigrade attributable warming in the Gulf of Mexico. And so you might expect that precipitation was increased by 7%. Certainly that's what I expected prior to these studies, including our own. And you can see here the three studies. Mark Risser and I made a best estimate of a 24% increase. The late great Gary von Oldenburg, a dear friend of mine, study came up with a best estimate around 16%. Then Simon Wang at Utah State did a WRF analysis coming up with a storyline coming up with 20%. The average of those all is about 19%, with an upper bound of almost 40% and a lower bound at the 95th percentile confidence interval of the Clausius-Clapeyron relationship. So that's a lot more than 7%. So you can argue a lot about whether or not the media interest in attribution is useful, but one thing it is clear that by analyzing individual events in some detail, one learns some science. And in this case, this has been supported by many other studies of individual hurricanes and tropical cyclones, that precipitation seems to always, in the intense ones anyway, seems to increase at a rate greater than Clausius-Clapeyron, usually 2 or 3 times. So I'm going to make a little aside about attribution, and what it really is an exercise in causal inference. And there are two really complementary philosophies of causal inference. One from Professor Judea Pearl, who's still alive, a professor emeritus at UCLA. And drawing from epidemiology, I think people understand this a little bit better if I put it in that terms. You would, if you had a new drug and you wanted to know its effectiveness, you would divide your study group of patients into one that receives the medicine and one that gets a placebo. This is a direct interference in the experiment, and in the climate change context, what we do is we do a simulation of the actual world, like I showed in that Pacific Northwest heat wave example, and compare it to a counterfactual world without the human changes to the atmosphere. And so that's a Pearl causal inference statement. Sir Clive Granger won the Nobel Prize in economics for a different kind of causal inference, and basically what you do is in our case we won't even use any models. This would be like a study where you were looking at the risk of heart disease in people as a function of their obesity, for instance. Where there is not an ethical reason or a practical reason why you could do an interference. And what you do there is you postulate a plausible cause, and you build a statistical model around that, and you may be able to make a statement depending on what you find. The issue here is there's a Latin word which I won't go into because I don't speak Latin, but it's basically causality and correlation may not be the same, and that's why you really have to have this plausible cause to have some confidence in that. But there may be other things going on, hidden covariates, as you'll see what I mean by covariates in a moment. But what I'd like to say is when you have studies that use both of these kinds of causal inference philosophies and they come up with the same answer, then you certainly have increased confidence in an attribution statement. So I'll start with the Granger because that's what Mark Risser and I have been advocating for quite some time that this is a complementary way of looking at attribution. And for Hurricane Harvey, we looked at the record, and you can see the total precipitation over the this is a 7-day precipitation in those two regions, with the small and large ellipse. And 2017 was way off the charts for the this is the annual maximum weekly precipitation. And our statistical model is, it's hidden, I'm sorry, a little bit. It's a generalized extreme value distribution, where for those of you who are familiar with it, this is something that you can model the tails of distributions with. And it's a 3-parameter distribution. It has what they call a location parameter, which is sort of like the mean, but not. And the scale, sigma, that's mu. The scale, sigma, which is sort of like standard deviation, but not. And then a shape parameter, c, which it tells the behavior of the tail of the GEV distribution. And what we did is we said, let's make these 2 parameters functions of a natural and an artificial, a man-made contribution. The natural contribution being an El Nino index, and the human contribution being the log of carbon dioxide, since that's proportional to radiative forcing. And the best fit model was that we had the location parameter be a function of both of those things plus a constant, and then the scale parameter, which sort of tells you something about the variability, being a function of just the carbon dioxide. And so we could estimate then the change in the probability of these, the change in the return period, which is like the change in the probability. And so in the small region, it went from a 1 in 30,000 year event to a 1 in 3,000 year event. Over the larger region is somewhat less, went from about 1 in 10,000 year to a 1 in 1,100 year event. But we were interested in this magnitude thing, and so we've been starting to call this a statistical counterfactual. And so we take that statistical model that I just showed you, and we kept the El Nino value that's the same as in 2017, but put 1950 values of carbon dioxide. And that's how we came up with these Granger attribution statements about the change in the magnitude, that in that large region it was a 24% increase. Now, Simon Wang, who I didn't know at the time, but now I know, he's a very interesting scientist. Just spoke to him 2 weeks ago in Chicago at our workshop where I originally gave this presentation, actually. And he used WRF to do what's now been called a storyline calculation, where he was able to get the storm to stall, and he ran 2 sets of simulations, one with global warming and one without, taking out, reducing the Gulf of Mexico temperature by about 1 degree centigrade, and then altering other initial and boundary conditions as appropriate. And he came up with a climate change. The climate change increased Harvey's precipitation by 20%. And then Geoghegan von Oldenburg did what is really kind of a more traditional attribution analysis. This is sort of the typical thing that the World Weather Attribution Group does, which is the highest profile event attribution group in the world, currently run by Freddie Otto in Britain. And they looked at 3 different models, 2 of which were high resolution global models, one of which was a high resolution regional models, and then used the GEV statistical model similar to what I just showed you to bring in the observations. And they came up with a likely range of a precipitation increase of 8 to 19%, and use these return period versus return value kind of curves to make these kind of inferences. So back to the main story here. So we have this range of estimates of the attributable increase in precipitation due to climate change, and how did those increase? How did such an increase affect the actual flood? Just because there's 19% more rain doesn't mean that there's 19% more flood, because that's not how it works. And so I met this fellow, Chris Sampson, He works for a company called Fathom, and came out of the University of Bristol in Britain, and they have a hydraulic model, which is a simpler flood model than a hydrologic model, that they'd already run the Hurricane Harvey storm using observed precipitation from NOAA. So we designed a storyline attribution analysis and said, okay, we've got this storm, the flood that was, that they demonstrated in a previous paper was a good simulation of the actual flood. And I asked them, what would happen if we decreased the precipitation by these published attribution statements? And so, for example, for Mark and my 24% statement, we decreased the observed precipitation uniformly by just this factor of 1 over 1.24, about 80%. So how much flooding would there be if there was 80% less rain? And we could, this is a 30-meter model, which for me was just incredible. I mean, that's about the size of a suburban house and yard. And so it's over the whole greater Houston area. And so you can really zoom in and really get at this question that I posed earlier. Did climate change flood my house? This area is in South Houston, which I chose because there were almost 9,000 homes flooded in this neighborhood. And this is the flood that was up in the upper left. There's a map here just for reference for people who actually know this area. I certainly don't. I've never been there. And so let's look at these two extremes, because it's kind of interesting to look at the range of statements. This is the really small one, the lower bound of a Clausius-Clapeyron increase in precipitation due to climate change. And you can see that there isn't that much less flooding in this middle panel on the left that compared to the panel above it, the map above it. But there is the flood is deeper, and it's about a foot deeper. And so, there is still, even though there isn't that much change in the area, there is a change in the volume, about 7% in fact. But then if we look at the high end, at the almost 40% change, you can see there's really a big difference in this map and the map at the top on the left. And indeed, if climate change increased precipitation by 40%, then many of the homes that were flooded would not have been. And of course, the depth of the flood is much greater. It's well over a meter deeper. And so even if your house would have been flooded without climate change, if it's 3, 4, 5 feet deeper, there could be a lot more impacts. Impacts especially get higher when it goes above the outlets in your house, which are typically about a foot or a foot and a half off the floor. So using these kinds of maps, we could make a crude estimate of the cost of climate change. Well, the 19% statement, that's the average of all those three studies, the best estimates, leads to a 14% increase in flood across the whole greater Houston area. And if you make a very simple assumption that the insured losses that comes from Deutsche Re and Swiss Re is $90 billion, and you say, okay, well, let's just assume that everything is equally valued and that homes are equally spread out, which is not the case, of course. We could make a very crude estimate that the attributable cost due to climate change of Hurricane Harvey and of insured losses is $13 billion, which is a pretty big number. Now, going back to that original statement about the two questions, the probability of the 19% increase is corresponding to a fourfold increase in the risk of this event. And so you could also say that the probability of a $90 billion insured loss in Texas was quadrupled because of climate change. All right, now to the next step. We've now gone from a degree of global warming to some more rain to more flooding. Kevin Smiley at Louisiana State University took those rather detailed flood maps, the 30-meter flood maps of the floods that were and the floods that might have been across these range of estimates, and applied them to census data and real estate maps. And this is the result with the real estate maps. And you can see that the damages are not distributed uniformly. Some areas where the darker hexagons are had a greater influence on climate change, had a greater influence. You can see that it's quite heterogeneous. And so, going into the numbers of this, basically with that 19 to 20% precipitation increase due to climate change, 30% of the homes that were flooded would not have been flooded without climate change. That's a pretty big number, actually, bigger than I might have guessed. And it shows, part of the reason is that people tend to live in the nicer places, or closer to the water. We'll talk about that in a moment, a little more detail. But he also found that 75% of the flooded homes, whether they were affected by climate change or not, were outside of the 100-year FEMA floodplain, and thus more than likely uninsured against flood damages. And this actually sort of explains something I didn't quite understand. NOAA's estimated loss for Hurricane Harvey was $120 billion, whereas Deutsche Re and Swiss Re said $90 billion. And I think that the difference is probably that a lot of the losses were uninsured. Kevin also used census data and these maps to ask some other questions, socioeconomic questions. He looked at income and race. He looked at single versus multifamily residents, and even looked at mobile homes. This kind of data exists in the census data. And we discovered that, perhaps not surprisingly, that there are pretty significant socioeconomic disparities of the impact of the flood in general and of flood and climate change. Now, the green house here represents those properties that weren't flooded at all in Harris County, and that's fairly the numbers of the percentage of these ethnic groups is pretty representative of the entire county, since most homes were not flooded. And the red house represents those properties that would have been flooded even without climate change. And you can see that even though only about 36% of the population is Hispanic, half of the flooded homes without climate change were Hispanic. And the orange one are the houses that were the properties that were flooded because of climate change. And again, about half of those were Hispanic. And so there's a disproportionate effect of the flood on what turns out to be low-income Hispanic households. And in fact, when you get outside of the, I'm going to skip that one. So these flood damages weren't distributed equally across the population, and the picture I showed was for the high estimate, but this doesn't change. The percentages don't change. That regardless of what precipitation change, attributable change you want to pick, the low-income Hispanic communities were disproportionately affected compared to the population at large. We also learned some other things that were kind of maybe a little counterintuitive. In the high-income, mostly white neighborhoods that were flooded, the richer you were, the greater your financial damage. But in the low-income Hispanic neighborhoods, the poorer you were, the greater the financial damage. That should be data. That shouldn't say data. That's supposed to say damage. I'm sorry about that. And why is this? And here's a little speculation: is that in both cases, the households that were flooded were near the water, but the views were different. In the high-income neighborhoods, the views were probably very desirable, very attractive. In the low-income neighborhoods, you're probably looking at a refinery, and so those would be the lower income, less desirable places to live. We also found that there was no statistical significance of trends in non-white, non-Hispanic neighborhoods. And again, speculating that we think it's because of when um, people arrived in the area, that the African American population has been in the Houston area longer than the Hispanic neighborhood, the Hispanic population, and so the more recent arrivals were in the more flood prone, had to settle in the more flood prone regions. But again, that's sort of speculative. So, we're trying to extend some of this analysis to other areas. Michelle Lee and Dave Judy and I are looking at the remnants of Hurricane Ida. This is a more complicated topography, and so the hydraulic model may or may not be appropriate, but they have these two researchers are at Pacific Northwest National Lab, and the project is called ICOM, a DOE-funded project at the labs. And their rift model is a more complex hydrologic model. And we can get at some other questions here. The first, the panel on the left shows the attributable change in the depth of the flood from the Hurricane Ida remnants in the East Coast. This is New Jersey and New York and Delaware. This is the region we looked at. And then the panel on the right actually gives you the rate of change of the height, how fast the flood rose. And this is important because a lot of the people that perished in this flood were low-income people that lived in what they call garden apartments, which is a euphemism for living in the basement. And the flood entered these apartments through windows, that were at the ground level, but at the near the ceiling of these apartments. And the people that died basically couldn't get out fast enough. They were elderly or otherwise mobility limited, and couldn't get out. And so the rate of change, the rate that the flood, how fast the flood waters rose, I think is an important factor. And so we're still analyzing this, but as you might expect, there is a socioeconomic disparity of fair significance. Changing gears a lot from floods to heat waves. One can actually get at this question about how many more people died because of increases in a heat wave. What the epidemiologists can give us are functions of are plots like this one of Paris, which shows a risk of mortality as a function of temperature. And there's a lot to criticize for these, and we won't get into that. But you can see that as temperatures increase, it gets rather the risk of mortality increases rather dramatically. And so, in some of these studies, you can make some attribution statement about the magnitude of the temperature change and say, well, it was a 2 degree warmer temperature. It was 2 degrees warmer because of climate change. And so you could go to this curve and say, well, the observed temperature was here, decrease it by 2 degrees and infer what the mortality rate that was versus the mortality rate that might have been. And so this again is that mechanistic kind of viewpoint of attribution. But Dan Mitchell did a different thing where he used these mortality rate curves on the previous slide and transformed the return value versus return period in temperature to the same thing in mortality. And in his paper with his colleagues, he stated that the chances of the actual level of mortality was tripled because of climate change, slicing in the horizontal, slicing in the vertical. He came up with 500 people died in Paris because of the heat wave. Now, across Central Europe, there are 70,000 excess deaths attributed to the event, and undoubtedly the fraction of those 70,000 folks that died because of the heat wave, some large number were the increase because of climate change is undoubtedly large. I'm not sure that it's possible to do it across all of Europe because we don't have these mortality curves for everything. You'd have to make a lot of assumptions, of which I'm certainly not a specialist. I think this is a good example of where these kinds of studies have to be really multidisciplinary. You have to bring in experts on heat wave mortality. So wrapping up, fundamentally, attributing impacts is really no different than attributing extreme weather events. The methodologies are essentially the same. It's still causal inference, whether it be Pearl causal inference or Granger causal inference. I think that the mechanistic questions, 2 degrees and, or 10 feet of flood or 14% more area or whatever, is somewhat more relatable. But there are times when the probabilistic attribution framework may also be informative. But care has to be taken because there are many pitfalls, and I've made some of those mistakes really. And we detailed some of these in a recent paper that Sarah Perkins Kirkpatrick led. I have a page full of references at the end. But the end-to-end attribution kind of goes like this. So this is the punchline: is that a degree of global warming led to 20% more rain, which led to 14% greater flooding, and that was 32% more homes flooded. And so that's going all the way from climate change to something that really affects folks it disrupts their lives. We also found, not surprisingly, that there are socioeconomic disparities. As I said earlier, 50% of the flooded homes were low-income Hispanics, but only 36% of the population is Hispanic, and even less would be low-income. And I want to leave this question with you: is this a quantification of environmental injustice? And my colleague Dave Frame says that you can't really quantify injustice, and to me, I think I would disagree. I mean, this statement about the disproportionate flooding of low-income Hispanic homes, I think, is a quantification. And given that low-income people have contributed far less carbon dioxide to in the global warming story, that seems like an injustice to me. The flood data, the maps from Chris Sampson in my paper, is publicly available at this website, along with some GCIS paper scripts to read the GeoTIFF information. So if you're familiar with mapping software, you can use this to look at it yourself if you're interested. And the COP27 just started, and this is a picture I stole off the Carbon Brief website showing the attribution studies that have been done. Been done on weather events. There is a really significant selection bias here, and the selection bias is that the distance from the event to the lead author's home is usually very short. And since there are more climate scientists in the United States and in Europe, there are more attribution studies in the United States and Europe than that's not representative. There are plenty of extreme weather events in the southern hemisphere that simply go unanalyzed for either lack of data or lack of interest from the scientific community. But there obviously are some. And I've detailed what the cost of climate change was, both either in dollars or in lives. And one of the issues that I think is going to be the hot thing to talk about, or the contested thing to talk about at the COP27, are loss and damages. And I'm maintaining that this end-to-end attribution methodology is a way of quantifying loss and damages. And so, that's another question I want to leave with you is how to deal with that. So here's a whole bunch of papers. I'll make the slides available so you can read that. And thanks very much. I'll take questions now.
Okay, thank you very much, Michael. And I think you've left us with quite a bit to think about. So I'd like to open up to questions either in the room or questions that might come up on Slido. So if you're in the room, please raise your hand. If you're online, again, it is slido.com, #CGD seminar, no S on the end. Okay. I might actually start off with the first question. And this is a little bit of a reach, Michael. So if you don't have an immediate answer, any thoughts that I think you can give in response to this? So this idea that we can make this movement from attribution claims to insights into environmental injustice, do you think there's any potential applications to this in terms of kind of forward looking in terms of the ways that we need to more equitably allocate our scientific resources to understanding possible potential impacts given the insights from these kinds of end-to-end attribution studies? And if there could be any potential insights that this type of approach could give us into how we might need to better provide information on impacts for the purposes of adaptation and resilience planning going into the future, especially with respect to increase in the magnitude of extreme events.
That's a lot of questions in one.
Yeah, sorry. I guess the main thing is just, do you think that there's potential ways that this might be able to intersect with something that is more future looking in terms of I guess going forward in a more equitable manner in the science and in terms of the way we prepare for climate change?
I'm going to deal with the equity question as a comment after I say something about the future. Indeed, one can use the same methodology to, the storyline analysis, if you have it, to go into the future. And so instead of making your counterfactual world colder, make your counterfactual world warmer. And Chris Patricola and I did this for the San Francisco Public Utilities Commission. Now, the Public Utility Commission is charged with redesigning the sewer system in San Francisco. It's over 100 years old. It's probably 150 years old in some places, and it needs to be earthquake retrofitted. But they also are charged with dealing with climate change, and so there's a sea level rise component to this, but there also is extreme precipitation. And what we did there is we asked them. We said, give us a list of the most impactful storms that you've had, and we'll try to see what those storms would have looked like in a warmer world. And so they gave us a list. We chose 6 of them, mainly because they were in the area where we had, in the time period where we had reanalysis data, and we ran it under mid and late century RCP 8.5 scenarios, I think. And we also found that the precipitation there increased at a rate greater than Supercalcius Clapeyron, and gave them some numbers. And then their consultants went and used that information to change their, what they call IDF curves, intensity, duration, frequency curve, which is their design tool. And I'm quoting Susan Leal, who used to be the director of the Public Utilities Commission, is now one of their consultants. And when she looked at these numbers, she said, and I quote, "There ain't no pipe big enough." And so the city is now having to rethink about how they will deal with storm runoff. In other words, not all of it will have to go through the pipe. Some of it will have to go on the surface, the roads, and be drained out into the bay that way. And so this is all expensive, but it is a way of using this kind of methodology to adapt to the inevitable changes in in storm severity. As far as equity goes, I mean, this isn't really a scientific question. I think this is a societal question. I mean, do we want an equitable world? I certainly do. I think most people do. But at the COP 27, I mean, the rich countries have to decide whether or not they want to pay for the climate change induced costs in poorer countries, who are not as responsible for climate change as the richer countries. And that's not a question I can answer, but I can answer if you do decide to do that. This is one way of putting a number on those damages.
Yeah, thank you very much. So we have a question in the audience. I think, can you take a technical question real quick?
Yeah, I certainly can.
Okay.
Mike, that was a very interesting talk. I was just wondering if you could say a little more about the design of this WRF experiment that tried to kind of quantify the impacts of Harvey with and without global warming. You said that they had somehow gotten the storm to. I'm curious. Is it a very short-term forecast? Is it worth being nudged? I'm just curious about how you designed this experiment.
Yeah, that's a really good question, because here's the papers. This paper by I didn't put it on here. I'm sorry. Christina Patricola and I also did a study on hurricanes, and we did 15 different tropical cyclones and storms, and found that we could not make a statement about the attributable change in intensity yet. That signal hadn't quite emerged from the noise, but we could make a statement about the attributable change in precipitation across these storms. And the way we did those storms is we did a hindcast of the storm that was, so a 7 or 10 day simulation at the most, and then did another hindcast of the storm that might have been in a cooler world, and we cooled off the ocean temperatures by an attributable estimate of the warming. But we also changed some of the fields aloft in the initial and boundary conditions. And we obtained those. You can obtain those in a bunch of different ways. Sometimes we use the CESM large ensemble. For the future, we definitely use that to perturb these fields aloft. But and we also used CMIP 5 or CMIP 6 historical versus historical natural ensembles to do those kinds of simulations, to do those kind of perturbations. And we've done this with other models as well. We've used the CESM variable resolution configuration with Kevin Reed and Colin Zarzicki to do a whole lot of storms. At this point, we've probably done 2 or 3 dozen storms. The statement we made about Hurricane Ian, that statement went kind of viral and caused me to be on TV a lot, which is an uncomfortable place to be, I'll tell you. But we made a statement that climate change increased the precipitation by about 10%, which was again twice Klaus's Clapeyron for the warming in that region. So that's how it works. Now, I made the comment about getting Harvey to stall because we tried Harvey as well with WRF, and we were doing so many other studies, so many other storms at the time, and Harvey was pretty difficult because you have to get the reason it stalled was there was a ridge in the right place, and we couldn't quite get that to be in the right place. And given that we had a lot of other storms, we kind of gave up on it. Whereas Simon persisted and was able to have a set of boundary conditions that gave a more realistic simulation of the storm. And there's some art to this because if this storm that might have been doesn't take the same track or a similar track as the storm that was, then you can't really do this. And that's what happened with Hurricane Sandy. Hurricane Sandy was, unfortunately, that was the first one where we ever tried this. It was a group with myself and a whole lot of other people, mostly at GFDL, and it's kind of hard to get Hurricane Sandy to take its sharp left turn and run into New York and New Jersey. And in fact, there's rather famous discussion about the European Center model being able to forecast that turn much sooner than the NOAA model. And so, as soon as we perturbed the simulations of Sandy with climate change, it would go out to sea. And so, not every, like I said, there's some art to this, and not every storm is amenable to this kind of analysis. But storms like Ian or Florence was even better, which don't take weird tracks. This is relatively straightforward. It seems to work pretty well.
Okay, thank you. Are there any other questions? Yeah, we have one more question.
Hi, Mike. This is Dave Lawrence. So, you showed that last figure you showed from the carbon brief, with all the attribution studies, looks like hundreds, maybe even more. Made me sort of start to wonder, like, where do we go from here in terms of attribution work? Like, do we need to keep doing this? It's public pressure, I guess, by being able to do this every time with a new event and reminding the public. But are you expecting to find new things, or are there things that we could be focusing on in the future? Obviously, the impacts is one thing you talked about today, but do you have other thoughts?
Well, this is a great question, Dave. I'm constantly getting calls from somebody. Can you do an attribution study about this event that affected me? And I get this from reporters sometimes. And sometimes it's like, I didn't even know there was an extreme weather event there. I'm sorry. And the answer is no, we don't have the resources. And so there is this clear public demand for this kind of information. Whether that's scientifically interesting or not, that's one question, but I think it actually kind of is. And Kevin Reed and I wrote an opinion piece in the inaugural issue of a new journal called PLOS Climate, where we argue that this, for some kinds of events, hurricanes being one of them, heat waves being another, that the technology has matured to the point where we could operationalize this if we want to. And in fact, the Met Office in the UK is close to it. I think the KNMI in the Netherlands is as well. And then I know there's some interest in NOAA finally in this, although I'm not privy to the details. And so, the reality, I think, is if the National Weather Service or National Hurricane Center did this kind of work, they'd do a better job than I can. I mean, I'm not a forecaster. I'm a statistician at the end of the day. They're going to make better forecasts, and they're going to make better hindcasts of the storm that might have been, just because that's their business. And so I think the credibility would be increased if these things were operationalized. But scientifically, I think there would also be something to be learned. I mean, like I said, this result of the Superclassius-Clapeyron scaling of precipitation with ocean temperatures was not expected by me, or I don't think by anybody. It's certainly not to be as robust as it's turned out to be. And so, you never know what you're going to learn until you learn it. And my feeling is if we had a lot more studies done by people that are forecasters, that are experts in these kinds of phenomena, we will learn lots. And the attribution community is rather small when it comes down to it, and is not funded at tens of millions of dollars at the most. And so I think there is something to be learned by doing more studies. And I think there's also this equity issue of the selection bias of people doing the events that that they experience. One of these is one that I did to get around that. It's right around here, Pakistani heat wave. And I deliberately chose that one for a couple of reasons. One of which is that I was really moved by news coverage of the tragedy, but also because it's like, that's not a place I'm going to go. So at least get one storm that far away from the lead authors.
Okay, thank you, Michael. And I think on that last point, just do you think that there would be value added in terms of how we change the trajectory of attribution research going forward, and maybe allocating resources from the countries that have scientific capabilities to the global south, where it looks like there's quite considerable gaps, I suppose you could say, in terms of these attribution studies in certain regions?
Well, if the COP27 agrees to a loss and damage fund, there would certainly be a lot more interest in the northern hemisphere, in the rich northern hemisphere countries, in the weather disasters of the poor southern hemisphere countries, because they would be paying for them. Yeah, I do. I think that suffering isn't limited to these thoughts, and I don't know. Yeah, I just feel it's important that we understand, where and how much the impacts are.
So are there any other questions?
Were there any online questions?
Right now there are none coming in. So if any do pop up in the last couple of minutes, I will send them your way to get answers. And I guess we're 3 minutes to the hour. So we'd like to thank you again. And yeah, if you don't mind making some of these resources available so that we can share them around. And also, I would very much, and I think maybe other people in the room would like to see the link for that event attribution studies from Carbon Brief to better understand where some of those gaps are. Thank you for taking the time and joining us.
All right, thank you. I'll put the slides on my Google website. So.
Yeah, you can send me a copy and we will distribute. Thank you.
Thank you very much.